What is the equation for? Yeah, there is that I over V, right? But then the other, or whatever, V over R, but V over I. But what they're talking about here is they're talking about this. Okay, this equation in your book says the resistance of a wire is based on, this is called resistivity. This means how much does that material resist current? How much does that material resist current? It's different for different materials, right? So different metals just have natural resistivities. Then guess what L is for a wire? Yeah, L is the length of the wire, and A is the area. It's actually the area, okay? So just so you can see what I'm talking about, if this is our piece of wire, this is L, and that is A. Okay? So then, what we can do is we can say this is rho Ln over An, and this is rho Lo over Ao. Of course, the rows cancel. And then the question says, yeah, rho is a, yeah, since it's the same silver wire that got melted down and reformed, then we can say it's the same. The silver wire is drawn in a new piece of wire that is twice as long. So L 2LO is equal to Ln. Okay. Does that make sense? I'm sorry? No, I don't think so. See, the new one has to be bigger than the old one. 2 of the old ones equals 1 in the new one. Does that make sense? Now what we have to do is we have to ask ourselves, what has to be true about this? Equal. Very nice. Right? Because it's the same piece of wire. Just because you melted it down and reformed it, it has to have the same volume. Does that make sense to you?
It's the same one.
Yeah, it's the same piece of wire. Right. So if I took a thick piece of wire and stretched it, does it make sense to you that they would have the same volume?
Yeah.
Because it's the same amount of material. So what we get here, the volume of the old one is L times A. And the volume of the new one is Ln times An. Right? Because it's the area of the end times the length. Does that make sense? So then, what we get here is the area of the new wire is equal to the area of the old wire times LO over Ln. And look up here, right? What is, I mean, we can pick either way, right? What is Ln? It's 2LO. So that's AO times LO over 2LO. So what happened to the area? Yeah, it's AO over 2. That's not right. No, that's right, yeah. Because the new wire is longer than the old wire, right? So what this means is, it means the new wire is thinner than the old wire, which should make sense. Right? No? Yes? Right? Because if I take a fat wire and I stretch it, the new wire should be longer and thinner. So now I just plug all of these relations in and cancel everything. So here, like for Ln, I can put 2LO, and I'll put everything in terms of O. So then An, oh, you know what? I'll make, yeah, An is AO over 2. This is LO over AO. And then I can cancel this, I can cancel that, and figure out my ratio. So I think it's 4, right? No, I mean, look, it's 2 divided by 1/2. So it means Rn over Ro is equal to 4.